again. We will continue this meetup and start the talks. So welcome again for being here. We are really glad to welcome you at Because. And it's our first meetup about Rust, so we are really excited. And so we talk about the introduction to WebAssembly and why targeted with Rust. And after you will have how to write a NodeJS package in Rust. So I think it's okay. We have around 20 minutes with the presentation and the questions, and that's it. So, okay. I will show you my screen if I can find it, and I cannot find it. Can I do magic? No. Yes. Wow. Techniques. So, first question, is there some of you who know already WebAssembly? Can you do something, a move, something? Yeah? Okay, some of you. Great. So, we take a deep breath and be ready to dive into a big web standard of the Web3C, the consortium of the web. So, yes, deep dive. And what we are talking about. First, that no JavaScript in the browser cannot do everything. And maybe we want to use Node.js to solve it, but can we don't know, or maybe we know actually, or maybe WebAssembly can help us, but what is it? Advantages, we will see the advantages and specificities of it. And finally, why Rust is a good choice to target. Yes, in the little corner it's WASM, how we name WebAssembly, so don't worry if you see this. So what is not possible to code in the browser using JavaScript? Two questions in one, and what is possible to code outside the browser using other languages? Do you have some idea first? Okay, we will see after if there's more imagination, but don't worry, we will talk about the example. Maybe you already know what is it. It's an audio editor that we can use outside the browser, but not in the browser. Another example is a video editor. And last example, it's Unity. Maybe some of you know Unity, to create some video games. So yes, it's cool. Let's take the use case. I want to make an audio editor in my browser. But what are the JavaScript limitations? First, JS was not designed for real-time computation. Inside the parentheses, it's a garbage collector. Maybe you know a bit of this, but we won't get too much in details indeed about it. But yeah, just know that JavaScript has a garbage collector. That means it clears the memory of your computer, of your program at a pause, but a random pause in your program, in your runtime. So that means you will have some break into your computation. So if you make an audio editor and there's break, the sound will break theoretically, sorry for my English, but you get the point. So you don't want to create something using JS. Actually, we can ship using the Web Audio API. That's what the browser gives you, some tools to make it like something which will be continuous, actually computation, real-time computation, but we see this after. And just for this point, note that yes, there's a lot of API in your web browser, but that's tools that you use. That's not JavaScript itself that can give you this tool. Okay. Another point, JS was not designed to manipulate binary data type. So, as I said, you can use a web API like WebAudio, WebGL to create 3D, to make 3D. And actually they are implemented in more low-level language like C, C++, or Rust. So the next return is, okay, with Node.js, I can use packages which contain some C, C++ of low-level code with actually fast and real-time computation, but can I use it in my browser? So I think you have the answer. Why not use them? Because those NPM packages are not for the browser, they are made for outside of the browser. So that answers the question. And we can go further about JavaScript. Let's talk a bit about it. You know that JavaScript was made in 1990, was created like 1995, something like that. I think, or I have to check it, something like that. And we want, as I said, we want today to make a lot of things in JS, but we didn't have the chance yet because, or maybe I correct myself. That was not the first time that we tried to do something else that can run computation fast and continuous in the browser, like Adobe Flash, Java Web Applet, etc. We can speak about more projects like this after, and especially one, Google Native Client. Maybe you heard about this. I won't go in much detail, but in some words, it was a project from Chrome that allowed users to run app in C++ directly within the browser. But it was disabled due to big security issues. The morning after they found this, they stopped it. Actually, the attacker would be allowed to escape the browser sandbox. And it means that the page web, yes, could access your computer stuff. So you know that maybe you know that your browser is a sandbox. What it means is that this is a virtual machine and running in your computer, and it doesn't have access to, for example, your file system on your computer. So if there's a breach and if someone can access to it, you know that it's the end of your computer. At least. So yeah, there was some trial, but I give you the link. I will give you also some links after. So how to overcome this and have more possibilities in the browser? You get it. We can use WebAssembly. And let's get back to our use case. So here is an example of a Node editor. Actually, it's a screenshot, but it's a WebAssembly. It's a project that can run in your browser. And you even can try it if you want. We won't try it, but I let it in my press. Okay, so a word about WebAssembly. How can we introduce it? So you have on the one end your browser, so the sandbox, the virtual machine, and you want to use machine language or binary data in your so in your browser. So something which executes binary data. So that's what they made WebAssembly. You want your browser to execute those binary data. Why is it interesting? Because there's a special memory management for memory management, and you have numbers type that you didn't have in JavaScript. Here, the JavaScript have only a float number. They don't have integer. If you didn't know, I lost my screen. Okay, cool. But as you may understand, assembly language is not made for humans. We cannot code directly in binary data. We will see maybe here that we can read it because there's two formats of the WebAssembly code. What is WebAssembly text format, and WebAssembly is only binary. So you see a module from WebAssembly here with a function. You can read some of it, but it's still really hard to understand. But at least if you want to debug, to edit, you can try. There's a tool to encode it from one to another, WebAssembly, WABT, and the point is it's really useful to go from one to another. So it's one thing that we can't do once we compile some code, we can go back. So that's the point. Okay, I think there's someone downstairs. Maybe we can call him to come. If you can. It's Matthias. Another example to make it more visual. So on your left, sorry, on this side, you have example of languages. Rust, C++, and C, and Go. Python is not really stable yet to compile into WASM. I'm not really agree with this choice, but okay. So what happened is the source code is go to through the compiler and it's targeted into WASM binary, and thanks to your browser here Chrome, you have a runtime that can run your WASM and discuss with JavaScript to do what you want. Yes, that's the point we will see after. JavaScript still is important to you. Okay. I checked the MDN's official documentation, and I think that's interesting. WebAssembly has huge implications for the web platform. It provides a way to run code written in multiple languages on the web at near native speed, and with client apps running on the web that previously couldn't have done so. So that means what? You have flexibility, multiple languages. You have portability because it runs on the web, so on main major browsers. And you have performance, so you have near native speed on the browser you have. So let's see those 3 points. Flexibility, so use multiple languages. Here is some of the languages we find on the documentation, the official documentation of WebAssembly. So you have the same as before, and some other, some I don't know, and some really old like Hovart. But yes, that's the main languages for now. And there's still already some of them that provide experimental support, but let's keep WebAssembly. Maybe you recall when we say that those languages compile into WebAssembly, it means they are translated from to another language. Just a point to know. So again, what can bring WebAssembly is bring large applications or game engines like Unity to the web without sacrificing performance or having to rewrite them from scratch. For instance, Google Earth was coded in C, and they managed to code it in compile it in WebAssembly. So now you have Google Earth on the web. So it was one of the first projects. You also have Figma that can so you see it. Its success is quite bad on WebAssembly. Also, you can integrate libraries from other language, and you know that there's a lot on libraries in C, C++, and Rust. For the performance, you can do performance-intensive tasks like computation for 3D games, stuff we already speak about. Most calculation could be done on the client side, that's you. This application no longer need a server, and as I told you, Figma is on the front-end part, so the client side part, and that's why it continues to work without the connection. That's a really interesting part. Here is a little code pen. I won't edit it on the doc, but you can launch it and you will have a little demo of the performance and in real time. But actually, the question of the performance depends a lot of your material, the hardware you have, the browser you have, and your computer and your connections also. So I think this is a rather complex question, and I think it's a huge area of study. And last, portability, as I told you, it runs on all browsers. For Google Chrome, it's engine V8, SpiderMonkey for Firefox, you have JavaScript Core WebKit for Safari, and Chakra for Edge. As I like to say, one WebAssembly file will run identically on all browsers, OS, and machines. So I won't get into more depth about this, but you know that it can run also outside of the browser, and that's really an important fact. So yes, WebAssembly is not a JavaScript killer, as we saw. JS act like glue code between the browser and WebAssembly. It won't replace it, but run alongside. And from one end, it discusses with the browser via the Web API, and from one other end, it discusses with the binary code. So from you was. And also Web APIs are only exposed in JS. If you want to get the event, some info from your browser, you still need to use JavaScript. And WebAssembly is important also because it won't disappear. It's a standard from the Web Consortium since 2017. Actually, there were big discussion between the major browser to define the specification of these languages, and even with the game engines developer. And I think there's something happening outside, but yes, so it's you want he will stay. Maybe a point, I told you the WASM can work outside the browser. It's called WASI, W-A-S-I, for WebAssembly System Interface, and it's your module from WASM that can interact with your system, with your host OS. It's really interesting. You can discuss with the system, file, the network access, and yes, interacting with resources. So that's the point. Let's get back to our use case. We can use a lot of languages, but which one we want to use? In my case, I'm totally opinionated. I chose Rust. And why target WebAssembly with Rust? I will finish on this. The main reason is that Rust memory safety guarantees make memory bugs really rare. In the world, with Rust, you are almost certain that you won't have memory leaks. Sorry. Thank you. And you, as a Rust compile once for all your code, Rust, you know that there's no problem in the future that will, no bugs that will happen. So a wide range of memory bugs are totally, how do you say, regulated and managed. Okay. And the last point, other reason for choice of Rust, it's the size of WASM files, because as you have to download your WASM file for the browser, for the web, to use them. If they are really as small as they are, you know that it will be quicker. Also, there's a great community, and Rust is known for its tooling, so you know that's other choice, other reason to choose Rust. Okay, do you have questions? I hope I was clear. I know I was a bit fast on some point, but we can discuss it really quick, and after we will go to. Is there some questions already? Yeah.
How mature is WebAssembly outside the browser?
Sorry, what?
How mature is WebAssembly outside the browser?
I'm not sure I get the word mature. Mature. Okay. WASI, actually, I still have to learn about it. I don't know about when he appears for the first time, but I think, no, I won't say bullshit now, so I don't really know. But there's also already some of projects that run in WASI, using WASI. Yeah, maybe.
So WASI is currently in its second technical preview. It's still adding features to it. Right now, you can't do double. You can't do there is a superset of WASI with WASIX that does support threading and some other bits and pieces, but it's kind of scattered evidence. There isn't WASI outside the browser is pretty limited.
Okay. So thank you for that.
Yeah.
But that's a really interesting point, because yeah, you code once your application, you know you can run it on all browser and on OS also. So that's really amazing.
It's the new Java.
Sorry.
The new Java.
Yeah.
Well,
Yes.
kind of. Is there some question? No? Okay. Maybe we will go to the next door then, and don't hesitate to take a drink now if you want. I will bring more fresh beer.
you.